We are now on time with all the, I'm having a look here. There is also some other participant that is joining, but I think we are almost on our plan. So I think that we can start right now. I would like to welcome all of you. I see a quite good number of participants here. My name is Marco Diciano. I'm in charge of the Research and Innovation Office in Innova Puglia, and we are representing here as Innova Puglia the project that today is hosting this webinar. And before starting, as the organizers suggested, I would like to remind you all that we are going to record all the webinar. And so if you have any problem concerning this aspect, you can please contact or write down on a chat some information. We see what we can do in case you have problem with this. You can write down on the chat or directly to Jana, which is also here present with the webcam already opened. And the second aspect that I wanted to remind everybody, of course, is to keep your microphone muted when you are not speaking. And yeah, according to the program, I will later on leave the floor to all the participants, all the speakers. And of course, we're also having some time for a roundtable, or at least a moment for question and answer. So if you please have any need or any question, you can write down on a chat. We will collect all the question, also with the help of Jana, and then we will try to address as much as possible of the question that you raise. In case we will run out of time, we will provide a question to all the speakers and leave all the material and the answers also afterwards. I know that Jana probably has already collected all the presentation and the materials that will be shared and will be showed together. So also because of this, you will be informed of the link and the place where everything will be stored. And so also later on, you can come back and see what happened and check the materials and the presentation. So I think we can definitely start, and I welcome you again. Also on behalf of the lead partners of the Social and Creative project within the InterAgMed program, and the lead partner is the Puglia region, and the Puglia region is leading this project that inside the InterAgMed program is called, it is funded like an horizontal project. This means that we, as lead partners, together with the Region of Puglia, are coordinating a number of projects funded within the calls of the InterAgMed program, and we will hear about that from the project officer of the MED program just after this very short introduction. It means that we are coordinating a number of projects with the aim of trying to support them in transferring and capitalizing results. So it means that we have a number of projects, a number of outputs, and we are trying within the framework of the program to capitalize results. We, as Innova Puglia, which is the in-house company of the Puglia region, we have the role of assisting the region in the implementation and management of the innovation projects for the regional public administration, mainly based on the digital technologies, and as well as for supporting the strategic planning of policy actions for territorial innovation. And since also 2012, Innova Puglia acts also as a regional aggregator for procurement and the central purchasing body of the region for tenders. So by doing this and by having these roles, we inside the project, the social and creative project, but also the actual project that is hosting this webinar, but also coming from the previous experience of the project that was called Thalia, we developed what we call the semantic framework platform within the aim of help the policymaker in identifying known and unknown relationship among projects, outcomes, documents, results, and so forth and so on. We try to do this not only on the, let's say, in an empirical way, but also by means of real-world concept analysis through what is we will talk also today, the natural language processing algorithms, and in a more general view, the AI, so the artificial intelligence branch of the digital algorithms for supporting not only the more technical aspect, where we see that AI has been used since many years, but also trying to support what is the area of the policymaker. So normally, when we talk about AI, we refer to an umbrella of terms where we have, for example, the intelligent objectives, we have the recommended systems, we have language processing, we have robotics, we have computer visions, and so on, you know. But not all these, let's say, parts of the technology have the same maturity. And today we would like to have together with the speakers, but also with the participants, a moment to exchange experience and expert point of view that are going to introduce some of the main application-based solution in terms of artificial intelligence targeting policy making area. So the main question is there room for artificial intelligence in supporting the policy making? So we are convinced that the President von der Leyen's call to make the next years what is called digital decade for Europe. And we think that this is a suitable approach which matches our regional development, for example, and smart specialization strategy in the field of digital transformation. And therefore, we encourage this AI development in real pilot application like the ones that we are discussing here today. And this is also the reason because we invited some of the experts that I will introduce later on during this workshop, but I would like first to leave the floor to Christoph Meyer, Mr. Meyer, that is the InteragMed JS project officer, which will give us the framework reference of the program. And later on, we will go, so the program that is hosting this webinar, and later on, we will go through directly the aspect related to the artificial intelligence and the application and point of view of the experts. So I think that time is ready now, and I would like to leave the floor to Christoph Meyer.
Thank you, Marco. I have been asked to give you an outlook on the next program period, which is actually starting this year. I have tried to start with the cooperation area. As you can see, there are some changes as well in the east as in the west of the cooperation area. There's still no official map, so I have done some homework just like this. I have tried to show you that it will be, generally it will be a larger cooperation area. You can see that we will expect Bulgaria and Northern Macedonia in the east, and 3 Spanish autonomous communities in the west to join the program for the next 7 years. There will be an overall objective, which is addressing the fight against climate change. In order to have an impact, this should be the underlying leitmotif of the next program period. Then we have 3 missions, as you can see. I wanted to focus this time more or less on the thematic topics of the program, not so much on the architecture and everything that is linked to the different types of projects, because I think for this time that we have to have a certain focus, and I thought perhaps this is more interesting for you to get an idea about how the topic of artificial intelligence could perhaps appear in the next program period and in the different topics of the program. So you can read the 3 missions. I don't want to read them to you because they are again in policy objectives and then in specific objectives, just to give you an idea how this process of designing the next cooperation program happens. These are the criteria how we are proceeding, not only us, we, that means it's a communication between, first of all, the European Union and then the program bodies that are involved. And these are the criteria, the underlying criteria for selecting the different objectives. Here you have the objectives, policy objectives. We have 3 and we have 5 specific objectives. I will now address the first 4 of them. The 5th, governance, of course, is also in line with today's topic, but it is very much linked to everything that has to do with the program architecture. And for that matter, of course, we can discuss it afterwards. I can give you some elements about it. But for now, for the introduction, I wanted to focus on the thematic issues. Here you can see the first part that is more or less covering innovation. This is giving you an idea about the different activities that are to be addressed with innovation. It has been, with all the analysis, there are a lot of preceding analysis, some external studies, some analysis done by the European Union. And then there's also the involvement of all the program bodies from all the countries that are participating in the program. It has been found out that in the Mediterranean area, we are still lagging behind concerning innovation processes. So this topic will still be an important topic to contribute to the overall goal. What you can do here is, for example, also concerning topics that you are dealing with in the horizontal project right now, like cultural creative industries, particularly now with respect to the post-COVID situation. It is also considering SMEs in the sense of externalization and internationalization of SMEs, just to give you an idea about the many indicative idea about the many topics that are summarized under the innovation for the next program period, leading then to climate change adaptation. Of course, this is the adaptation is a central point in the next program period. This is mainly because, as you know, probably when you have read something about it, Mediterranean, focusing on Mediterranean, there's to be expected a lot of impact from climate change also on our area. Risk management will be one of the priorities also. Projects are supposed to address the impact of this topic, the impact of human activities that somehow are in interaction with climate change. Then we have identified as an important circular economy as an important potential, because we see that there is a lot of possibilities to improve on this. This is also on one hand, this is possible on the management side, and it could also address directly resource governed activities like waste management, for example. And finally, as you see, I've been asked for a very short introduction. You have everything that is connected to biodiversity, green infrastructure, and environment. On that side, we are looking forward to receive projects that are diversifying management methods and presenting opportunities for the mentioned activities. In the end, I wanted to inform you that also on our website, you have the information about the ongoing status of what we are preparing for the next program period. So that you can also download the current documents that we have. This means all the analyses that have been published. We are now in the process of drafting the third version of our next operational program. And for now, you might probably find the second version, and it will be updated, of course, as soon as all the program bodies have given their agreement on the documents that we can publish them. So just to give you a very rough, very short outlook on what we are currently preparing.
Thank you, Christoph. I hope you will have time to stay with us also for any further questions, and also for the following roundtable to discuss some of the aspects related to these issues. I would like now to leave the floor to Mr. Alan Horst, the Dean at Faculty of Economics and Business of the University of Rijeka, which is also a partner in the Social and Creative project we are talking today, and this is hosting this webinar. The floor is yours, Mr. Horst.
Thank you. On behalf of the Faculty of Economics and Business in Rijeka, as the host of this virtual workshop, it is my great pleasure and honor to welcome our partners from the Social and Creative Project who are present here today. Mr. Marco Di Ciano, I think, as project coordinator, and Mr. Christopher Meyer from Joint Secretary. I would also like to welcome all our presenters and lecturers who are part of the first panel. Mr. Colin van Noort from the Taltech company and EU Commission expert, Professor Sanda Martincic-Ipšić from the University of Rijeka Department of Economics, Professor Pasquale Lopes from the University of Bari Department for Informatics, and Giuseppe Rizzo from the Links Foundation in Torino. And our presenters and lecturers who are part of the second panel, Mr. Bernardo Rondelli from CIRIS Academic Barcelona, and Mr. Francesco Molinari, International Researcher and Policy Advisor. I would also like to welcome all participants, representatives of government of the Republic of Croatia, representative of local and regional government, representatives of the private sector and companies involved in the artificial intelligence development, and scientific community interested in the role of artificial intelligence in the development of strategic guidelines and policies. My predecessors already explained the importance of this workshop for our project and for the future development of adopting artificial intelligence in development of strategic guidelines and policies. The fact that this workshop is fully booked tells us enough about the interest about this topic. The role of artificial intelligence in today's world, in the companies, and its role in future development is not imaginary anymore. It is the present and the future of the business processes, and thus in adoption of strategic policies in local, national, and EU level. The creation of European framework for the further development of artificial intelligence will determine the position of the European Union and all its member states on the world competitiveness map. In year 2018, the EU issued a coordinated plan of artificial intelligence in which it was emphasized that all member states are encouraged to adopt and exchange with other member states national strategy or programs for artificial intelligence by mid-2019. Strategy should define goals, state goals related to artificial intelligence and suggest a legal framework for its application. Unfortunately, the Republic of Croatia has not made this document until today, which is why we are extremely happy that the response to this workshop is so good. We in Croatia have top experts in the field of artificial intelligence in innovative startup companies, in local and regional government, in scientific community, some of which are present here today. And I personally hope and believe that through this workshop, we will contribute to the development of planned documents and also to the use of artificial intelligence in business and strategic policies, and thus to development and competitiveness of the Republic of Croatia. The Faculty of Economics and Business in Rijeka and our experts offer expertise and knowledge and are at the disposal to the local and state administration. For the end, I wish all lecturers and participants a successful workshop and quality discussion. although the workshop is organized in a virtual environment, I'm sure that this will not diminish its contribution. Thank you.
Thank you, Dr. Horst. Let's go now in the core of the activity of this workshop. And to set the scene, I would like to ask Mr. Colin van Noort, who is a PhD researcher at the University of Technology in Tallinn. And we know also he's an external expert for the European Commission's AI Watch team, where he is contributing together with the others to the landscaping of the use of AI in public services in Europe. And you are also part of other study team on exploring digital government transformation or other studies on European programs like ISA Square or IPS or through the European Commission's JRC in Seville. So the floor is yours. You have almost 20 minutes and please take your floor.
Yes, thank you, and hello everyone. Greetings from Tallinn, Estonia. So I prepared a presentation. I hope it's visible.
Yes, it is.
Okay, thank you very much. So yeah, so in this presentation, I'll give you a bit of an overview as was just introduced on what AI currently is meaning for governments and the various usage that we already identified, both my own research, but also as part of the expert advice I've been doing for the European Commission. So my name is Colin van Noort. I am indeed doing a PhD in Caltech University. I really focus on the public value and the effects of AI in government, with all of its paradoxes and caveats. It's, of course, a very interesting and innovative field. So why are we doing this, right? So why so much interest in the use of artificial intelligence? I mean, definitely the recent years, but I have a feeling that it has only, you know, given even more attention from policymakers this year. So there's a lot of interest for having AI, and especially then also growing interest of using AI for the government. That is different from the past, because in a couple of years ago, and even now still, governments are seen as this vital player for being, you know, for helping the development of AI in their society, either as a facilitator by providing more data for companies to build machine learning models on, stimulating the startup scene, helping establish different kind of collaborations, providing funding, etc., or to as a regulatory role to, you know, make sure that there's framework conditions. But of course, governments are also a user of AI themselves, so they can help tackle various social challenges, and this is a role that is now becoming increasingly more important, as of course also there's links between, you know, government needs to know what AI can do, so to be more effective in facilitating and regulating. So as part of the research that I've been doing, so this is an overview of some of the cases that we identified in, well, already last year's report on AI in public service, part of the AI Watch. So we found 230 different AI use cases across the EU. This is definitely not a complete view, as you can imagine, but this is just a sample of different cases that we could find or were submitted to the team. And from that, of course, we can find out some interesting points. So how AI, for example, is used. So what we could identify is that currently, that from the cases that we have, a large portion is used to provide in the general public services area. We do have a slight bias towards having more AI cases that are used by national administrations. 30 of the cases are part of the local level, but I have a feeling that in reality, local cities are doing much more than we could have found. Often we see a lot of chatbots, other forms of some kind of predictive analytics system, the use of computer vision or rule-based expert systems. What is also perhaps noteworthy is that despite the disruptive potential of this technology, we see that AI is often still very much used only as in a very incremental fashion. So it's only having slight changes to the way organizations work, and we have not really witnessed bigger changes in work practices, but of course, this may change in the future. And that's particularly because there are some challenges still in really moving from data analysis to the adoption of AI and really integrating it into work practices, and whether successful pilots and perhaps research projects really scale up. And this is one of the main barriers. So in that respect, there are some interesting examples, right? So I try to create, especially because of the workshop, is AI in policy making. So how is AI currently being used and may also be used in the future in more diverse ways than we can even imagine today? So at the moment, we see a lot of AI that's being used to help detect different social issues, either to make sure that it doesn't escalate, or to help policymakers to understand what is the general sentiment or some of the local issues that they may have overlooked. So a nice example of this is a system used in Dublin City, which is called the Dublin Beat, and that gives, based on Twitter data, an overview of the different kind of issues that are being discussed on social media about the city, what is the sentiment, and it gives like a general overview every month for the city to base new policy on. So this is of course very helpful for policymakers to understand what is going on in the city. But of course, you've got to keep in mind that social media data is not fully representative of course, of all the issues. And there's definitely some barriers to using this data for many reasons. Alternatively, there's a growing use of AI to estimate potential effects of new policy. So you can compare ex ante what could be some of the effects, and you could change your policy accordingly. So this can either be economic effects, but also trying to understand potential citizen sentiment on some of the examples. So this new policy modeling is growing more and more advanced because of the use of AI. Alternatively, AI can also be used to improve the decision-making process within policy, mainly because of the previous stages, but also to, for example, have it easier to have citizens included within the policy-making process. So the Dublin Beat is one example where we see citizen input online gets more integrated into policy-making processes, but it can also expand even more, such as what we see in Citizen Lab, which is a private sector platform that many municipalities are using. And the AI can also help to analyze easier, to give more structure in all of the citizen input that they may have provided on the citizen participation platform, but also think on certain petitions or large public consultations. AI makes it much easier to aggregate all of these insights, and that make, of course, policy making perhaps more inclusive and more in line with citizen needs. Alternatively, AI can be used to monitor the ongoing implementation of policy, which we can see in Satikas. This is used in Estonia to monitor the grass mowing requirements in many agricultural subsidies. So it gives policymakers an overview of how the implementation of policy is going. Or alternatively, you can see an example in Amsterdam where they use object detection to also see how trash collection is going and where to adjust, for example, the routing of the garbage trucks. And of course, evaluation of policy is also very possible with new micro data and other forms of data sources to help understand if policy is actually a success or not. Alternatively, we see the creation of new public services. So the use of AI, like this robot used in Barcelona to help the elderly. So we're creating a really new kind of public service. It uses robots instead of people to help them care for themselves. Alternatively, we see the enhancement of information services. So this prevalent use of chatbots that many governments are using to help citizens find the information they need, or in this project, Bureaucrat in Estonia, where they really try to completely change the way citizens have to interact with governments. Rather than having to go to each of the office, they want to create one chatbot to connect all of the different databases of the government. So they can ask one question in one portal and they automatically get routed to the correct administration. Also, of course, redundant and perhaps tedious processes can get automated with AI, which leaves more time for experts to focus on more complex cases and to perhaps come up with new jobs that are much more value adding than checking forms, for example. Another example that I included is in Belgium, where they are already using AI technologies to help unemployed people find jobs that are close to their competences, and which only requires minor reskilling. So people can upload their CV and answer some questions, and they give an overview of jobs that are actually quite in line with their skills that they may not have realized before, and it can help them, of course, find a new job faster. Alternatively, we see a lot of uses for AI to improve the internal management of the public organization. So this is to either improving their own recruitment services, as this example in Sweden, where Tengai is actually a robot face to help the recruitment process. So instead of talking to a person, this robot assesses your competences and whether you're a suitable. Of course, this is still in collaboration with experts, but it plays an increasingly more bigger role. And it's argued to have this recruitment process less biased. So because the robot doesn't check how you look and how what kind of background you may have, but really just to see if you are suitable for the job. And that, of course, leads to a better inclusion of skills and diversity within public organizations. Alternatively, we see AI to help organizational resources be more used effectively, or that AI is used to improve the cybersecurity, such as in Estonia too, where the main data sharing platform also uses AI to detect anomalies in the cybersecurity, so they can be detected easier and addressed quicker as well. Alternatively, you see the use of AI to help public procurement processes themselves. So making tedious forms either be done automatically or checked automatically, or even predict whether a certain offer is likely to go over budget or not, based on all of the previous experiences on that exist in the database. And of course, a lot of uses of AI is used to help prevent fraud and corruption. So one of them here is the Veripon, Spain, also where they try to detect false police reports, because that's apparently a big issue in the police services there. And this system helps them to detect these false reports that can actually have big consequences, of course, for both the police time, but also for fraudulent investigations. So despite all this potential, right? So there's a lot of different uses. We still see that we are in a very preliminary state with the use of AI, because there's still quite a lot of different gaps and barriers that are present, limiting the use of AI in government. Despite perhaps the readiness that governments have with regard to pre-existing digitalization, there's still many barriers, as one of these academic papers describe, that lies both in the technology implementation, the laws and regulation, the ethical concerns, which I will also highlight a bit later in this presentation, and the overall readiness of the society. And all of these factors, they limit the current deployment of AI in government, and they should also be taken into strong consideration by policymakers who are interested in going forward with AI, of course, because you know, the ambition may be there, but many of these barriers may be overlooked and not given sufficient attention. And then in particular, I would like to stress that the technologies may be there, right? We have a lot of interesting projects or pilots, but if there's no use of AI in more active sense, there's also no value. That's always what I say: no use, no value of AI. And taking strong consideration that what could be is not always what is. So organizations that may be tempted to use all these technologies because it is potentially very important and very beneficial should also really take a close look at if this is also what really happens. So check all these barriers to innovation. And this is, for example, an overview that I found that from my own research that highlights all of the different factors that partially or greatly influence the AI-enabled innovation in the public sector. So, and this is, of course, data is one part of that, but there's many more different factors that really go beyond just the development of AI, and also really check like if this is use sustainable, because otherwise we run the risk of coming into an ever pilot, or that the technology is there, but people do not really use it into their daily practices. And that's also why digital transformation is not about technology, right? Innovation comes from people, and they have to use this into their own work. They have to integrate this into their normal work, and organizational practices have to change accordingly. And that is very difficult because this is an organizational change question, not so much technology. Of course. So then, it's particularly for AI, there's a lot of different ethical challenges when governments start using these technologies, right? That go even beyond just the lack of funding or the lack of skills in the own organization, but there are serious risks that also, of course, have to be taken into strong consideration and mitigated as much as possible. Otherwise, the potential downsides of AI overshadow the potential benefits. So these is particularly related for policymaking and public services, that AI can lead to decisions being based on a black box, right? So we don't really know why the AI is recommending certain things. And this has very dire consequences for the accountability and trust in government if we cannot even explain why we take certain decisions. Of course, that directly translates to issues in liability, right? So when something bad happens because of AI's decision, who is to blame, and who should take responsibility? Likewise, AI uses a lot of data, and often even more sensitive than before, very, very detailed, that people may not always be aware of, that is being gathered for AI. Or we start using AI more and more, such as these examples with the object detection, that people may get frightened of, that there's so much more cameras and eyes and surveillance monitoring the policy. Of course, there's a lot of issues with bias from using historical data for policy making, because the data has been gathered in a certain context, and it can only amplify certain feedback loops that you maybe don't want to optimize. Cybersecurity that is used to, on the one hand, help public administrations. At the same time, it's also a risk of using AI because AI can be tricked, and there's many different ways to limit it. There's different power relations that change, right? So you need to be aware of that too. Existing social contracts between citizens and the state may change when AI starts becoming more and more used. And of course, there's serious consequences if governments get it wrong with these kind of technologies. So for the last slide, I would really like to stress, despite all the potential, keep in mind also the potential downsides, and be very reflective of AI. So public sectors have this user role, and it should be encouraged, that's for sure, but also keep in mind in your own organizations, do we have all of the factors there to really move forward with AI and make sure that we get public value from AI? So not see AI just as the goal themselves, but check if citizens use it and if the downstream it has a value, and it's not just a privacy monster, so to speak, but there's really a clear benefit associated. And if you get that, please make sure that it scales up within the organization and even outside of the organization, because all of the public administrations face similar issues, and they would really like to know what AI is successful and which is not. I thank you very much. I hope it was a very interesting presentation for you and a nice Kickstarter for this great program that I already saw with all of these great speakers. So if you have any questions, please ask them now, because I unfortunately cannot join the whole workshop. Thank you.
Thank you, Mr. Van Noort. Yes, I always remind everybody that there is a chat for the question, also for the coming speakers. And I would like to, use your spare time before leaving to ask you an opinion on these aspects specifically. Your presentation was really very clear, and we also have to say that the year 2020 has a huge number of production. Let's say we have the white book on AI, on the communication 65, then we have the European strategy on data, we have the data governance regulation, we have the digital market service regulation. Everything has been done in 2020. So this means that I would say that we are on the cutting edge of this aspect. And we also know that, for example, three main aspects, which are data protection, digital identity, and cybersecurity, are, of course, part of this European vision on artificial intelligence. But I would like to ask you, are those the most relevant aspect to develop an AI centered on the human being, or do you think that something is still missing when we talk of policy-making application of AI?
Yeah, thank you. That's a very good question. Also, a very difficult to answer question, of course. So the points that you raise, these are essential, right? That's also been put forward within the European policy makers to, make sure we have these basic requirements, such as the data protection, the privacy, making sure it's in line with human values. I think that what is also still very important is to not encode all of this at the start of many of the projects, but also check this after we are starting using AI. So in many of research that I have read, we still don't really know if the use of AI in all these different services really makes such a significant improvement compared to maybe traditional methods. I'm saying, for example, the use of a very simple logistic regression versus a highly advanced deep learning methods based on thousands of different data points. And very often with the use of these kind of technologies, especially with trying to predict certain social outcomes, it's not always that much better. So then the question also raises, do we need to gather all of this data from citizens to have 1 or 2% improvement, right? So is it still worth it? And I think that's not a question you and I will be able to answer always. This depends on the project, but it still requires this reflection. And I think that's also what really means to be human-centric AI, as is also pushed in the EU, is do we really, make a difference? And is this not just a technology that we think works, but does it really, in the end, does so?
Yeah, indeed. 2020 was, as I said, let's say the killer year of not only for the pandemic, but also for the issues related to the data treatment, or even this aspect of human being behind the AI. So really, thank you for your presentation and for setting the scene. And yes, please take your time, stay with us as soon as much as you can, or we will let you even have feedback on the forthcoming discussion that we're going to have later on. I would like now to go to the second speaker of this session today. We have Ms. Sandra Martinic Ipsic. I suppose I pronounced in the right way, almost, not well, not so good. Anyhow, she's a full professor at the Department of Informatics and University of Rijeka. She's a team leader of the development in the Horizon 2020 project called MESOC, which is aiming to exploit exactly the AI to generate textual analysis for assessing the social impact of cultural policies and also practices in European cities. And we also know that you are quite well involved also in activities for the machine analysis of social media and also infodemics and wave and misinformation or fake news. So I think you have the right experience to provide us your point of view of expert on this topic, and I definitely leave you the floor for the coming 20 minutes. The floor is yours.
Thank you very much for the kind introduction. I will share my screen now. So today I'm going to talk about natural language processing, and I didn't say for AI, but for policy text analytics, but I will put my talk in the framework of artificial intelligence, but I will be much more focused into natural language processing. Why do we do it? And I will finish my talk with the example of the MESOC project. So where do we stand today? I'm starting really very globally, and the volume of data in 2021 is estimated to be about 74 zettabytes. And it's been assessed that the size of the data, the size of the digital universe is doubling in size every 2 years. So we are witnessing extremely large quantities of data, unprecedented quantities of data. Why is that? Because we do have the number of users which is growing on a daily basis, but not only users. Users are using many devices, or as I like to call them, different kind of data generators. And with all these different kinds of data generators, we produce different kind of data. As we see in the example, it can be text, it can be video, it can be images, it can be numerical data, sensor data, and so on and so forth. So we actually generate huge quantities of data that are really different in the nature for the analysis. Also, because of these huge quantities, the velocity that new data is generated is huge. So we need the real-time capacity to process this kind of data, which leads us to the key term, which is big data. And it means that big data is to be processed beyond standard processing capabilities. So now to modern analytics into the age of big data. Actually, with modern analytics, we do try to analyze the outer world, the social world, the world of social media, of internet, of external data, which is not the data that we collected in our internal information systems. And by doing so, we do different kind of data analytics, either on social networks, where we know that we collect a lot of short messages, either of Facebook, Twitter, Reddit, whichever social network it is. Then we have a lot of online writing in online news, but also in blogs, a lot of multimedia video and images. And this all analytics is nowadays based on the use of artificial intelligence and maybe data science, which is kind of intersected term with the artificial intelligence. And it is all enabled by big data processing. And my talk today is actually how this modern analytical tool can help to inform policy making and maybe monitoring of some policy implementation. And as I said, we do it with the help of artificial intelligence, and I would like to debunk this term. Artificial intelligence is not new. Artificial intelligence has started in the 50s by the most traditional way of expert systems and rules that map cognitive processes in the brain. Later in the 80s, the quantity of data was higher, so different kind of machine learning principles, which actually mean that we learn different patterns or regularities in data from large quantities for large data at the input. And the second name that can be applied to machine learning is statistical learning, where we actually learn some kind of statistical models from the data automatically. And recently, in last 10 years, the subfield of machine learning has arisen, and this is the deep learning. And deep learning is what we face nowadays as the major breakthrough of artificial intelligence into different aspects of everyday living, as we saw also in the nice examples that Colin provided in the plenary talk. So first, I would like to debunk what is deep learning. So deep learning or deep neural models are actually models that deep means that they have many layers. And these layers are mathematically simple components with a very complex organization. And how this complex organization will be put together has raised many different architectures. I will not go into details, but here you can on the daily basis find different architecture, which is kind of better, improve, and so on. But take home message is that deep learning is actually a mathematical formalism which has a lot of parameters, and these parameters in mathematical formulas on function or functions should be trained with many calculations, which means that the deep data or deep learning is now enabled by the huge quantity of data and by learning parameters from huge volume of data enabled on the really powerful hardware. So this is prerequisite if we want to go into deep learning. And now I will reflect to the field of the natural language processing of dealing with text, how the field has developed in recently in last 2 or 3 years. And my slide actually depicts the number of these parameters that are trained in the deep learning models. So you can see that from the January till July of 2020, we witnessed more than exponential growth. And recently, this growth is even bigger because Google Switch Transformer is the size of 10 to the 12 number of parameters. So why I'm not, take-home message is not to remember this, but to have the impression that deep learning is growing better because we do have the more data. Actually, these models are Google models, Google Brain models are using all the available data that Google can index on the web. and then they train extremely huge number of parameters. And these are the most successful models, but these models are beyond the reach of the government or beyond the reach of the local government or even the research company, because arena for the players in this field are actually left only for Facebook, Google, and big companies. But still, there are a lot that can be reused by their works, and so some examples of successful using of existing model is already existing. Now to the natural language processing. And natural language processing, I would like to say that this natural language processing means that we automatically process the textual or unstructured data by the means of computer. And natural language processing comes at the intersection of linguistics and artificial intelligence, because when we deal with text, we need to know something about linguistics. So here I position NLP at the intersection. And from the perspective of different artificial intelligence technologies that I mentioned, natural language processing can use standard artificial intelligence, machine learning, or deep learning. And from the perspective of task, natural language processing is very much interested into understanding of the human language, which means that natural language understanding is a huge sub area of natural language processing. And the other one is natural language generation, where we try to generate descriptions from the data. And now back to text analytics. So what I have explained is actually engine which is driving this text analytics. So at the input, we can have different web text, public text, or different kind of textual data. And by means of natural language processing, we search for values in this text. And then on the front end, we can develop different applications for marketing, financial investment, drug discovery, or policy making. I will skip this one because probably I will be too long if I go into details. But on this slide, I have listed different kinds of applications that can be used. And we already heard that chatbots and virtual assistants are really very much used. Also machine translation, also summarization, speech recognition, and so on. But I will not go into details because I would like to go into the second part, which is actually one use case that we have developed for MESOC project. Beside MESOC project, we are also researching the infodemics in Croatia during the pandemics, where we deal with a lot of information spreading, sentiment analysis, and analysis of the whole social media space in Croatian. Beside that, we do also research on the summarization and extraction and semantic similarity of texts. So now to the MESOC project. So MESOC project is measuring the social dimension of culture. Actually, project is trying to assess the value and impacts of different cultural policies and practices. How this social value and impact creation can be monitored or can be put into some level of maturity and be useful to the policymakers. The core of the whole project is the MESOC matrix, where we actually organize 10 cultural domains according to the Eurostat classification into heritage, archives, visual arts, and so on. And 3 crossover pillars of the structural model are coming from the new European Agenda for Culture, where we try to assess this impacts creation to the health and well-being of the local people, to the urban and territorial renovation, and the people's engagement and participation. And in this project at input, we deal with text, where we do have 2 types of documents: pilot studies and scientific studies, scientific papers. So here is actually what I had on the previous slide, the whole matrix, where we try to analyze text and the output according to the taxonomy, according to the organization of the mesoc domain in this matrix, which contains 30 cells. So we developed, or we are developing, to be honest, Mesoc Toolkit, which is a georeference visualization tool that enables also semantic search of the documents in the Mesoc domain. It has two types of documents, pilot studies and scientific. For now, we only deal with scientific papers, and we are developing the pilot studies in different cities across Europe, and it can be visual in the Mesoc matrix. So Mesoc Toolkit can be also used as text analytical tool that actually from the text that you are writing to describe some cultural policy or initiative, you can upload it and your text can be then analyzed and some suggestions of transition variables or impacts according to description of your policy will be derived. And also because as we heard that the main drawback of artificial intelligence, one of the main drawback is to be black box. We plan to expand this inference part with ontology to shed some light how we derive or how do we infer suggested transition variables. And finally, tool is also semantic search tool. A semantic search tool where we can retrieve documents that are most similar to your uploaded document or more similar according to the set of variables that can be indicators of your policy or process that you want to implement. So now to the visualization part. So here we have different documents scattered around Europe, and by clicking on the tag, we can analyze what's behind it. And always we start with the learning by natural language processing different kind of models from the textual data, and then we develop some BI dashboard or business intelligence dashboard that is actually capable of measuring social impacts and monitoring the transition process. So when you upload the document will be nested into Mesoc matrix. And some indication how much of document is dedicated to each category of the Mesoc matrix will be used to assess which possible impacts and variables are inherent for the uploaded document. Also, similar documents can be retrieved which are similar according to the content. And this can be also contextualized by the content only in one category, which is relevant for your analysis, or it can be maybe deeper by analyzing the structure of the variables. And all of these should be explainable, so should be linked to some knowledge representation or ontology that explains how these automatic processes are being inferred. So we used a lot of text classification, automatic extraction and georeferences of location, a lot of content analysis with keyword extraction and topic modeling, and finally also variable extraction. And at the end of my talk, I would like also to say a few words about our other research, which also includes complex network and language complex network, text mining, development of textual corpora, data analysis, and we also do research, a lot of research for the Croatian language. So what can be maybe interesting is automatic genre differentiation. Who is the author of and what is the language of some text? Then how to extract concepts and knowledge from Wikipedia, how to calculate sentiment on the Twitter data, and even more importantly, how to predict missing links and the spreading mechanism on the data. And we have also done some analysis of scientometrical or co-authorship networks. So this is the team mostly of my collaborators, PhD students, and over the years we had a lot of past members that contributed to our research. So at the end, I would like to thank you for your attention, and I hope that we have time for some questions.
Yes, thank you, Ms. Martin.
Sanda Martincic.
Martincic.
It's difficult. Let's call me Sanda. It will be easier.
Very appreciated. Yeah. Of course, thank you very much for your clear view on the aspect related to the natural language processing, of course. I always ask to Jana to collect further question that I'm going to miss in case I miss something on the chat. I saw that there was a question from Meyer, and I think that the specific question for that raised Meyer probably is much better addressed in the coming session on the ontologies. And I see a question for Sanda coming from Milena Stefanova, which says and asks, which methodology did you use to define the ontology of the MESOC project?
Milena, thank you for the question. It's under development. Actually, it's not some firm concept where we would like to integrate the taxonomy of the all indicators and variables, and on the other side, we would also like to explain the context in which impacts and generators are constructed. So the ontology is not done yet. I am actually very brave and I presented you the work in progress. But as the illustration, what can be done, because here we do have some kind of policy making of analysis or analytics of policy making processes scattered around Europe. So I cannot answer you directly which methodology, because it's not done yet. We are trying two or three different approaches, and maybe Francesco in his talk will also tackle this part of the problem that we are dealing with. So,
in fact, yeah. Thank you, Sanda, for this. Also, from my side, I think that also the question that raised Christoph Meyer could be addressed later on to the following speaker. I'm talking about Francesco, but also Bernardo Rondelli, probably. I have instead a question related mainly to the algorithms that I wanted to ask to Sanda, and the question is it concerns the fact that the use of algorithms has an issue related to trust. We said before that we have machine and we have humans, and so there is a trustness among these. This issue has, of course, an impact on one side on the fact that the algorithms generally are not public. For example, because they are the core of patentable innovation, for example, or in case on the other side, when they are made public, the solution or the services built on them are not transparent or even not easily interpretable in their way of functioning. is there something, I mean, do you have an opinion on how could we work to overcome this problem of trustness and also of understanding of the usability, and how the algorithms made the choice of what we provide to the algorithm as input in order to provide us some output. So how could we work to overcome this problem, which seems relevant for the point of view of the policymakers, because we are talking about here the application on the policy side.
Yes, this is $1 million question in artificial intelligence. So it is really about not only trust, but also how transparent is the process. And when we are using deep learning, for instance, this is a black box method, which is not transparent even for the developers sometimes. It's extremely complex. So I will not say that this is going to be easily solved, but I would like to go into maybe with reason. This is my personal thinking. Maybe we should tackle the problem not by how transparent it is, but how useful it is, how easy to use, how many times prove that it was useful, then I'm starting to gain trust and I'm starting to use it. So make it simple, make it very intuitive for use, and then try to explain some functionality as we are trying with ontology to shed some transparency into the inferring procedure. Because this, by shedding some light, maybe even inferring procedures are not completely perfect, but by shedding some light, the user may gain some knowledge and reapply it in the real use case scenarios. So this is my standpoint, but answer to that is going to be the struggle in the next several years in the field of artificial intelligence research, I think.
Food for thought, I would say.
Yeah.
Definitely. Thank you, Sandra.
Thank you very much. Bye.
I would go now still in the field of this natural language processing for the analysis of policy text to Professor Pasquale Lopes. He's an associate professor at the Department of Computer Science at the University of Paris, and he specialized in many field related to this aspect on the recommender system, on information filtering and machine learning and modeling and so on. And he is also the technical manager of the let's say semantic framework, so the technical core of the Social and Creative project, and I expect he will present also a kind of demo today for this webinar. So Pasquale, the floor is yours.
Thank you, Marco, for your kind introduction, and good afternoon to everybody. So today I'm going to describe our techniques for natural language processing for the analysis of policy text. And in particular, it's a quite different perspective with respect to the previous presentation. We are not using deep learning techniques, but it's another bunch of techniques taken by natural language processing. And I will present the semantic framework tool. The semantic framework is the main backend of the platforms developed in the context of the two horizontal projects in the InterRegMed program. The two projects are Thalia and the Social and Creative. The main goal was to provide some pilot services for different kind of stakeholders, such as the project partners, the policymakers, for supporting different activities, such as the community building or the thematic engagement and the facilitation of interaction. In order to achieve those goals, we have analyzed all the results which have been produced by all the projects in the context of the Interreg Mediterranean program to define what we call the semantic model. That is a structured representation of concepts along with their relation. In this picture, I will show you the main pipeline implemented by the semantic framework. First of all, we gather a collection of documents. So we gather all the reports and the deliverables which have been produced during projects belonging to the different communities of the Interreg Med program. We also gather some policy or scientific manuscript and articles, and we group all this document in a collection of documents. After that, we performed a quite complex natural language processing pipeline in order to identify and extract the most important concepts from the textual content of documents. For us, a concept is an atomic textual unit occurring in documents, which could be composed by a single word, but also by a sequences of words. And then starting from this list of concepts, we generate a semantic model, which tries to arrange all the words, sequences of words, but also text fragments and word documents in a kind of geometrical space. In order to build this geometric space, we rely on the so-called distributional hypothesis, which claims that the meaning of words is given by their use. So terms which are used in similar context share a similar meaning, and they will be arranged very close in that geometric space. So by analyzing, for example, a huge collection of documents, we could say that, understand that, for example, beer and wine are different words, but they have a very similar meaning, since they usually co-occur and are used with quite more or less the same words. For example, drink, glass, party, pizza, alcohol, and so on. This is the main intuition behind the distributional hypothesis. There is a lot of math behind these techniques, but of course I will not provide you with all these details, but I will show you concrete examples of services which were built by leveraging the semantic framework and the geometric space I told you before. So this is a set of, these are the services which were built for the Thalia and the social and creative projects. I will start with the demo of smart search and then the policy design variable. I hope everything will work properly. I start with the smart search. The smart search service provides two main services. The first service is a semantic search engine. As the previous speaker told you, the semantic search is able to return documents according to their semantic relatedness and not the exact matching with the query terms. So, differently from a classical search engine, which returns documents if and only if query terms occur in the documents, a semantic search is able to return documents which are somehow correlated to the query terms. And the second service, built of course on the ground of the services provided by the semantic framework, is an automatic summarizer of documents. Each document can be automatically summarized to produce a shorter version of the document itself, of course, by preserving its meaning and the key contents of the original text. We can summarize on the fly documents which are tens or even hundreds of pages long, and it's up to the user to choose the length of the desired summary. So let's start with the demo. this is the system, and we can access the first smart search service. As you can see, the smart search service is like a classical search engine. We can enter a query, but in this case, we can choose a collection of documents on which to issue the query. We have different collection of documents, and in particular, we have a collection for each thematic community of the InterRegMed program. So we have 8 different thematic communities. We have the blue growth, green growth, and social and creative community, efficient buildings, renewable energy, and urban transports, sustainable tourism, and biodiversity protection. So let's start with a query. For example, we use the query oil, and we select a specific collection. In this case, I'm selecting the collection Innovation Axis 1, which groups the documents belonging to projects in the thematic community of blue growth, green growth, and social and creative. If we issue the query, the system will return a list of documents. It works like a classical search engine. So we have a list of documents, and we have this relevance bar, which highlights the relevance of this document with respect to the query. Of course, the longer the blue bar, the more relevant is the document with respect to the query. Before examining the list of results, it is worth to notice that the system returns a set of related concepts. In this case, the system returned concepts very similar to this query, which are extra virgin, olive millers, olive oil, olives, polyphenols, and so on. So it seems that this query, these words, is used in this collection in the sense of olive oil. And we know that oil is a polysemous word. It has more than one meaning, at least in English. So these are the related concepts. It means that if we analyze the geometric space which are built by the distributional hypothesis, oil and these concepts will be very similar and will be very close in that space. Now, let's try to issue the same query, but to change the collection of documents. For example, we use this collection, Low Carbon Economy Axis 2, which contains all the documents of projects in the thematic communities of related to efficient buildings, renewable energy, and urban transport. If we issue the same query, so the same query oil, but on a different collection, of course, the list of results will be different, but if we take a look at the set of related concepts, we could observe that now the related concepts are related to fuel oil, oil diesel, diesel gasoline, diesel propane, kerosene. So it seems that in this collection of documents, oil is used in the sense of combustible and not in the sense of olive oil. And this distinction between the two different meanings of the same words is obtained in a completely unsupervised way. There is no intervention by human, but it is the distributional hypothesis that now, in this case, if we analyze the geometric space built by the distributional hypothesis, we could observe that oil is very close to these other concepts. Now, if we take a look at this list of results, we can see that there is for each result the name of the document returned by the semantic search engine, a brief summary, and we have the name of the project to which the document belongs to and the overall budget allocated for the project. We could ask the system to show some metadata associated to each document. In this case, we have the date of production of this document, some keywords, target audience, and also the budget allocated to the deliverables. These are specific metadata specific for this usage scenarios, but of course, we could integrate and we could represent any metadata we could deem as useful. We could also take a look at the partner details. So in order to this project, we could list the partners and we, for each partner, we have the name, the fact that it's a lead partner of the project or not, the overall budget allocated for that partner, and also the country. If we click on the document, we can obtain we link to the document to the web page of InterRegMed website, and we could also take a look at the document. Original PDF or words or of the document. In this case, the document is 18 pages long, and it's about bioenergy, biomass, and so on. If we, come back at our system, and if we do not have time, for example, to read the Word document, we can ask to the system to automatically summarize the document. We can choose the length of the summary, for example, in terms of number of sentences or original percentage of the original length. For example, we asked the system to produce a summary of which is 3 sentences long, and on the fly, by relying on the semantic, on the geometrical model, on semantic space built previously, the system is able to provide a very short summary, which is related to biomass fuels. So it seems it's quite relevant. But of course, if you would like to have summaries which are longer, we could also proceed with asking more sentences. Finally, the system allows to arrange all the results in this screen also on a thematic map. So we ask the system to show on a map the distribution in Europe or around the world of partners working on these projects and the budget invested by these partners for producing all these deliverables. So we asked to the system to show the thematic map, and in this case, the system can show the map, and you can switch between a map containing only lead partners or all the partners. In this case, the map contains just lead partners. There is a specific marker for a partner, and each marker is related to a specific community. If we click on a specific marker, we have the name of that partner, the fact that it's a lead partner, the name of the community, the name of the project, and the overall budget invested on deliverables by those partners. And in this case, we have also the 2 deliverables on which the partners has contributed, the partner has contributed. So this is the first set of services built by leveraging the semantic framework. In order to end my presentation now, I will give you some details about the second service implemented by using the semantic framework. The service is called Policy Design Variable. The Policy Design Variable is a more advanced service, which is more for maybe for policymakers. And the service allows you to create a cross-correlation matrix using some concepts which could be autonomously defined by user, of course, by leveraging the knowledge contained in a specific collection of documents. The main objective of this use case of this service is to help policymakers or some expert user to complement their top-down vision with a bottom-up approach, which leverages all the project outcomes contained in deliverables, technical reports, policy text, to possibly unveil meaningful connection useful to the policymaking process. As for the smart search, I will show you the potential of this service by using a demo. So this is the list of analysis. So when you click on the service shows a list of analysis which have already previously defined by other user. And for each analysis, you have the name of the analysis, the collection on which the analysis was performed, the author of the analysis, the creation date, and a brief description. We could create a new analysis, that is, we create a new cross-correlation matrices, and we can ask the system to create a cross-correlation matrix, and we could define the number of rows and the number of columns we need. For example, we need a matrix 2 by 3. We select a collection of documents on which to perform the analysis, and we ask the system to generate the structure of the matrix. In this case, we have an empty structure of the matrix, and in order to go on to proceed with our analysis, we have to define each concept on each column and each cell, each row. So each concept could be autonomously defined by user. For example, I can define a specific concept, for example, marine renewable energy. I use a label, and I use a textual description for defining my concept. In this case, for example, the text could be as long as you want. Maybe you could also upload hundreds of pages of text related to the definition of this concept. In this case, I use a very short sentence for defining the marine renewable energy. And this is the energy which can be harnessed from the ocean or the marine wind. It's comprised of 5 main types according to the origin of the extracted power, namely marine wind, surface waves, tides and currents, and thermal and salinity gradients. When we ask the system to generate a semantic representation of this concept, the system performs on that text, a natural language processing pipeline similar to the one used to process documents, and the system tries to identify in the text all the concepts which we are able to find in our semantic model. So the system has tokenized the text, has removed words which are not useful, for example, some conjunction or some we call stop words, words which are not interesting for our semantic analysis. We can decide to unselect some token which are not useful for defining marine renewable energy. And the system also, in order to enrich this representation, also provides some other concepts which seems to be correlated to this one. So we can select and enrich this representation with other concepts such as I don't know, mild winters, Atlantic Ocean, wind farm, or hot summers, or renewable, and so on. When we save and close this window, the system has defined the first concept, and there is a tooltip which provides you, which reminds you the list of concepts you have used. Of course, you can also select and unselect concepts according to your definition. Once we have finished with the definition of all the concepts on the columns and on the rows, we can ask the system to fill in the matrix. In order to show you how to fill in the matrix, I just show you an already previously defined analysis. This is a cross-correlation matrix which crosses together. On the columns, we have the 3 main pillars of the Thalia vision, and on the rows, we have the 6 features identifying the MED projects. When we ask to fill in this matrix, the system fills in each cell by retrieving the concepts which are mostly correlated to the concepts on the column and the concept on the row. So in this case, we have a set of the top 10 concepts which are correlated to community scale partnership in this case and cultural anchoring at the same time. Start by looking at the concept in each cell, it is possible to formulate 2 interpretations. We have a descriptive interpretation based on the assumption that those concepts mirror some evidence coming from the deliverables of the running projects, and one prescriptive, which highlights the gaps in the previous analysis and the possible action items for the policymaker willing to reinforce some of the correlation documented in each cell. So this ends my presentation, and this is what I have presented is a concrete way to provide support to the policymakers, starting by this services leveraging the semantic framework platform. So thank you for your attention, and happy to answer to your questions.
Thank you, Pasquale. And yes, also for you some question, but because I heard that there is some time constraint for the following speech, I would jump directly to Mr. Rizzo, and then we will come back for the questions and also for the other aspects, so that we can end the session related to the natural language processing for the analysis. So okay. I would like to leave the floor to Mr. Giuseppe Rizzo, who is the team leader at the Links Foundation, the leading innovation and knowledge for society in Turin. And he's a background in computer science, and he's a web evangelist, fascinated by smart web application and knowledge extraction technique. And he also the technical manager in the Horizon 2020 project called Easy Rights, which is using AI for NLP, so natural language processing, to facilitate the immigrant lives in kind of understanding the implication of regulation that concern or affect them during the staying. So the floor is yours.
Thank you. Thank you, Marco. Thank you also, Paolo, for accepting to postpone the questions. Okay, let me share the screen. All right, it's going to be a long presentation, but I'll make it short since I have another meeting running in a few minutes. Just let me know if you see my screen before going forward.
Yes.
All right. Thanks again for inviting to this interesting event. What I'm going to present is the implication of AI for a specific topic that everybody now is carrying and is working on, is social good in the broader sense. But before giving an example of what we mean as a social good, let's first frame what we mean as AI. And I used to collect a statement published by Russell and Norwig, considered among the fathers of the recent AI, that says it's the study of agents that receive percepts from the environment and perform actions, in the sense that AI now is about perceiving what is around us as we humans have built the world, and also trying to perform some sort of human intelligence in a very specific and narrow way. We will see how. So we are all aware about the value of AI. Recent publication by McKinsey and Company have stated that by 2030, AI is going to generate $13 trillion, actually boosting the GDP overall of 1.2. And this picture was taken 3 years ago so far, before even the pandemic. I would even think that now these numbers should be revised. And at the time that they made the picture, they even said that if we assume companies that have already gone digitized, even those, they can improve their performance or improve the capability of making business and serving customers. It's interesting to see how much they could do that. Even the travel industry that is highly digitized since the early days of the industry, they can even boost more than 100% of their capability. And it's another interesting chart here, this bar that you can see in the middle of the slide. It says that for the 100% of all interest and addressed companies, more than 30%, they can actually generate value in a manner that without AI, they couldn't do it. It's actually an interesting message, this one. So AI is not just an improving or something that will generate more than what they have already, but they can even enable new value. It's interesting message. So at the end, by 2030, 70% will have adopted AI solutions. So what about other industries? Nowadays, it's hard to think about any industry where we don't see any AI applied. So why now then? As we have seen in the previous presentations, AI is around since the mid of last century, but now we have these four elements that they put together in such a manner so that we have a lot of progress in algorithms for data representation and learning. We have the culture of storing curated data. We also now have computer machineries able to process high volume of data in a shorter time, and in particular, a Boost next-gen accelerator has been the first commercial applications that actually show AI can work. And we got addicted about that, so that we increased the expectations and we fueled this pipe. So we said at the beginning, Russell Norwig said, any agent that can receive percepts and they do actions. Well, what sort of actions? Anything that can require from us 1 second of thought. And this is a statement given by Andrew and Jane in 2018 and still applies so far. What AI cannot do? Well, writing a coherent, on-topic, innovative, creative thesis yet. I'm sure all of you is now wondering, what about GPT-3, and that got quite popular recently? Well, it's certainly a first step forward, but still it's highly based on what GPT-3 has seen and the experiences has collected. Nothing about the process of creation as a human being is used to. So taking a picture of AI, we can certainly see two branches: the narrow intelligence, as Norwig and Russell opposed in 2010, and the general intelligence, the intelligence that can actually be compared and relate with human beings. So now, today, we are near halfway to the general intelligence as GPT-3 has presented quite recently. So this is the vision that we usually bring in the projects where we work. The AI that is designed and applied for making humans better humans, because it can bring more evidences, reason further, help to make our choices and improve the life of all species on this planet. We know that AI is a very broad term. There are several tools. Some of those have been mentioned already. I wouldn't go too much into the details, but just such a chart for explaining the interplay. We have heard data science, we know AI, we know machine learning, we know deep learning. Well, all of this is in a big pot. There are some overlaps. So for instance, data science overlaps with AI because it actually develops software, but at the same time also develops analytics, slides, and charts. While AI is based on software, and the techniques are, as we mentioned, as we heard from the previous presentations, machine learning, deep learning with neural nets, knowledge graphs also quite important. So what is the take-home message? Just for, you know, the broader message. AI tools are utilized to create technologies. That's an important message. And this technology is used for sensing the world as we know it, for producing mainly nowadays language and vision capabilities, offering personalized experiences. I'm sure Netflix, Amazon, you know, this is the sort of personalized experiences that we refer here. So now the point is AI in public services. That was a leading concept that we brought in the work in Easy Rights. So initially we started to explore what has been already published and discussed, and there is this interesting report published last year from the JRC. It says that Europe is moving, it's actually pushing a lot to AI, but with an important message. It's going to be a trusted AI based on truly European ethical and societal values, borrowed from the European Charter of Fundamental Rights. So basically, we are shaping as European citizens an AI that can live with us and respect all the species on the Europe perimeter, Europe, United Nations. What we have seen from such a report, we have seen a shift of AI concerning governments, because so far governments acted as regulators. And this is what we have seen from many technologies. And in particular, recently, GDPR was an excellent example. Governments are like doing a step back, trying to make a picture and regulate different actions. Well, with AI, something is changing. Actually, I would even say has changed, because governments started to become users for delivering interesting services to customers, namely citizens. This is another interesting chart available in the report I mentioned. And the first line lists a project, an initiative presented earlier by Colin. It's quite interesting to see this stuff. Well, it's computer vision and identity recognition for farming and satellite data. We also have a lot of other interesting AI applications, mainly for either creating a more human sort of some sort of communication with the offices, and providing improvements to the current information systems at disposal in the different countries. And this actually wraps up what I just mentioned. Chatbots and digital assistants went quite viral through the different governments. But at the same time, we have seen also the spreading of intelligent database predictions and simulation through recognition, such as the satellite images, as Collins presented. Well, we posed the question of what about migrants, and in particular social inclusion. The idea was indeed enabling people who arrive in a new country to get involved in public society. This is, of course, a very hard well, I would just say complex concept to apply, because it requires numerous dots to be aligned all together. In particular, the person who arrives needs to understand the knowledge. And understanding the knowledge most likely means getting up to speed to the culture, get up to speed to the language of the host country. So that this is a typical example that we have started to work on. It's the migrant who's looking for a job. And so she first looks for the necessary information and documents in order to apply for the job and be able to handle an interview. So we understand that this is very contextual based. Such an application depends on the country where he arrives, and we know it. Most of us have been abroad, and we know that this is typical process to handle. So, however, she would need the necessary understanding of the language and the lexicon utilized in the job in order to be able to hold an interview. Likewise, also being able to speak in a comprehensible manner. So this is the use case that was formulated at the beginning of such a European initiative. And so that we came up with such a claim that is backed up by a technology that I will give you an introduction briefly in the following slide. So the claim is an intelligent system that generates automatically easy instructions to migrants, so that when she arrives, he knows what to do, where to do, and how to do for accessing the service. And then also topic-specific course generator relying on automated technologies for language processing, supporting the learning of the specific knowledge needed, for instance, to access the job, and also followed by pronunciation exercises. So all of this is the contribution of 3 technical partners into this project, and in particular, Links is focused on generating automatically easy instructions to migrants. So now think about what is about bureaucracy in Europe, all over Europe, from Greece, Italy, Spain, UK even, because we have a UK partner as well involved in this project. It's all the same story. Bibles, lengthy, verbose, hard even to understand for a mother tongue. So the challenge is, we know, as I mentioned, understanding the knowledge in a comprehensible and actionable fashion. So we as a Links, we are developing a tool based on AI, and in particular NLP, that basically takes those Bibles, chunks them into portions. Those portions are the steps, and for each step we identify pivotal information such as what is about the step, where to do in order to access the service, when to do, and how, meaning documents and the procedures in order to get to achieve that step. So the lesson learned, it's still learning since it's an ongoing project, but this is the first picture of the lesson learned. We can simplify bureaucracy by addressing one of the most painful pillars of it, so verbose and complex procedures. And this is, as you can see, we have basically reverted how we thought government can be involved or can utilize AI, not just as a regulator, but even as user of AI in order to provide a better service. Conclusions, we know that AI is big value nowadays. It's a buzzword, but beyond the buzzword, there are some practical and pragmatic values being discovered. So nowadays, AI is not yet general. It's a long way in order to get general AI, but still, it can automate 1 second of thought. And in particular, if we apply such an idea of AI, we can certainly help public services and governments in order to provide something more impactful to citizens and users in general. And this is a success story that is about Easy Rides. So please, if you're interested, go to the website and ping me for any questions so that I will detail you everything else. So that's all. Yeah, please, Marco.
Yes, thank you, Giuseppe. Very, very interesting your point of view on these topics, and especially the application side. I know that you have timing constraints. I don't know if there are questions. Otherwise, I will just ask you a very quick question concerning the, the multilingualism. We know that natural language processing is something that concerns the language itself. So it means that it has to do with a specific language. Now, because you're working on different sides and different countries, are you targeting these issues, or you normally expect that, for example, an immigrant is going to reach a place and normally he knows, at least at the beginning, some part of the language of the place where he's temporarily hosted? Or do you have some input, or do you have some suggestion concerning this aspect related to the multilingualism?
Thank you. Good question. We do support the languages of the host countries, namely Greek, Italian, Spanish, and English. Nevertheless, the way how we produce what we call the pathway, namely the easy instruction, is very short text, such as names of locations, names of organizations, time expressions that don't really need to be translated in the mother tongue, in the language of the migrant, because they are very short sentences, words. But the multilinguality is addressed in terms of the host countries we support. And so far, we have 4 different languages covered.
Good. Thank you. Thank you for this clarification. Anyhow, if there are questions, we will also come back to you and use your willingness to provide some point of view from your experience, from your side. So if you have time constraint, please take your time, and we will keep back in touch again.
All right.
Thank you.
Thanks
Thank you,
again.
Mr. Ritz.
Bye-bye.
Good. Now, I don't know if I asked Jana to help me in addressing the question, if I'm missing something concerning the what is passing on the chat, but I don't know if we still have some time for a quick question for Pasquale, if there are questions. And because of this, I would ask Pasquale to, before going to the coming session, let's say on the ontologies and the policy visualization and tools, I would start raising the discussion, a quick discussion, and ask to Pasquale his point of view on the question that raised Christoph Meyer some time ago at the very beginning, concerning the question is like this. I don't know, Pasquale, if you can read it on the chat, but anyhow, Meyer was asking if we could think of suitable indicators to make the results of the contribution of AI to policy making process. So a kind of measurement of contribution of AI. So let's say a kind of way of defining criteria to say that this application is more suitable than the other, or maybe identify also other criteria. Do you think this is a process that is possible to start? Is it any experience, or do you have any point of view on this specific topic? I know that you are involved on the technicalities of the application, but probably also thinking in a broader way and trying to investigate possible indicators or possible criteria to measure the usability of AI at the policy making level. It could be also useful for as a feedback for the technical implementation of the different algorithms.
Thanks for the question, Marco. You are right. I'm more on the technical side of this topic, but I follow the discussion, of course, in the context of the social and creative project. I think we can consider the toolkit I have shown before as a decision support system, which allow you to explore deeply all the results which have been produced in the context of specific projects. And in my opinion, those tools could be very useful and could help policymakers to have a clear overview, a clear picture of what has been produced in the context of specific program. So in my opinion, the fact that you can explore the partners who have worked and how much they invest, for example, on a specific topic, the distribution, the possibility to have a clear idea of the geographic distribution of the partners who have worked on specific topic could allow to policymakers to devise new specific policies. For example, they can have a look at the map and maybe there are some nations, some countries which work for renewable energy more than other countries. So in my opinion, I'm not able to answer to specific indicators, which specific indicators could be provided and could be devised by using these tools. But in my opinion, the possibility to have to deeply analyze all the results of the specific program could give some indicators to policymakers. So
good. Yeah. So thank you, Pasquale. So you mean, it's not the job of the technical aspect to define the indicators, but probably if we are in the position to have this indicator, maybe also from the people who is in charge, also from the policy level definition, or even on the ontology, on the visualization tools and so on, that we will hear in a while. If we have this criteria, probably we can use these exactly as we thought could be used, the rows and columns in the matrix that you showed you before. So it means that we don't have an answer for Christoph at the moment in terms of suitable indicators, but if we have the definition of this indicator, we can try to merge together in order to compare the different policies on the same indicators coming on the different documents, on the different set of specific analysis, because we know at the moment we assess and we analyze the project's deliverables, but the tools is perfectly working also on strategic documents, on specialization strategies, or on technical documents that each possible policymaker would be able or has been able to provide and to produce according to the strategy that they are working on. Yes. So we will keep this in mind also for the following speakers, but anyhow, and I would also ask Christoph Meyer later on to come in, to step back in and also clarify if we are misleading the question that you raised.
Sorry, we have one more question. Will we leave it for later?
Yes, probably. Yeah, I would leave the question because I don't know. I don't have sometimes it's raised to me that there is some time constraints, and I don't know the different people how much time they have. We normally had the timing starting from 2 o'clock up to 5 p.m. So we still have almost 40 minutes. So I think that we have time for the very last two presentations and then for final question and discussion in a short roundtable. So this is the time for Mr. Rondelli, who is director of Series Academic in Barcelona, Spain, a European consulting firm designing and implementing the strategy and policy solution for higher education, research, and innovation. So I would leave the floor to Mr. Rondelli, and you have your 15 to 20 minutes for your speech, please.
Thank you, Marco. Good afternoon. I hope that you can see my slides.
Yes, yeah. Indeed.
Perfect. So I will present you an approach derived from the field of artificial intelligence, in particular in the field of noise representation, very much related with the problem of policymaking. And we'll try to discuss with you why it could be interesting and relevant for decision making and for policy making in particular. As you know, policy is an imperfect decision making process, as mainly all decision processes, and this is very much based on the capacity of contextualizing information and considering different information to support what is clearly a bounded rationality, no? And evidence-based policy making, which is becoming more and more relevant in our society, especially in that moment, is a way to, in some way, support this bounded rationality. The problem of evidence-based policy making is the fact that you need to consider several elements. So when we think about insights and policy recommendation, we are just looking at the tip of the iceberg, no, and just the top. But we have a lot of elements which are not visible, but are very much relevant and have a strong influence in the way in which finally we have our insight and possible policy recommendation. And in particular, today I will focus on the aspect of the data management and the data integration, which is as the beginning, no? And when you need to collect data, and you need to make this data available for then developing your analysis and support interpretation. And the issue here is that, as all the policymaker here knows, so we have been working too much in a very silos-based approach. So every department in government, from the municipality to the state, tend to organize the information at the silos level. This happens in several organizations. And then we have a lot of problems when we want to share information, when we want to make this data interoperable. And this is really the issue. So how we can create this, this idea of creating a semantic web where we can really integrate information in a way that can be easily exploited by everyone and hopefully also openly. Here is where our ontologies in terms of conceptualization and representation of a specific domain can play a role. And I think that are going to become more and more relevant in the future, because we have been discussing a lot about deep learning, data mining, so statistical or statistical method. And now I'm going to talk a bit more about knowledge-based method. So the fact that ontology is a representation, is a model which is based on a specific knowledge of the reality. And the idea here is that what we call the ontology-based data integration approach, or also knowledge graph approach, which is a technology that is growing a lot, which is the idea that we have different data sources that can be distributed everywhere. And then throughout an ontology, we are able to build a layer which allows an integration between the different data sets. And then we can access this information without knowing exactly where these data are, because we just query the ontology, and the ontology is connected throughout mappings to the different data sources. And this is a bit the model that we can exploit, and is behind what we call the link and open data approach, which is becoming more and more relevant. In particular, if we talk about ontologies are increasing available. So the availability is increasing a lot in this here, and we can have very complex ontology. Let's think, for example, at the ontology of the gene, how it works, or then we can have a more simple ontology about how student, how we can model the concept of student. And we have more and more of these from different field and for different aim, and we can exploit more and more these available ontologies. And I will give you an example of how this can be done. So I give you an example of a project which has been developed by the Tuscany regional government with the aim of building a regional observatory for research and innovation. The idea there was that the region needed to exploit data available in different repositories for informing policy on one side, but also for communicating better what Tuscany is doing in terms of research innovation. And the idea here is that they were able to collect data coming from different sources. You have data from the regional level, data from the national level, data at the European level, or also data at world level. So for example, in this case, the clinical trial, European project, data about students, data about publication. And then they created an ontology, which is this model of the higher education research system, which has been connected to system for visualizing and interpreting this data. And this ontology, by the way, become the national standard. So now you have an ontology in Italy, which is the standard for higher education and research, and can be exploited by also other organizations because it's available, it's completely public. And using this, they also had the problem of integrating different taxonomies, because you know that especially when we talk about science, we can have very, very different taxonomies. So we have, for example, everyone is aware about we have the classical science-based classification, like the ERC, the European Research Council. This is the national disciplinary organization of science in Italy. Or then you have the more classical organization of science using what they call the bibliometric reference, which are based on journal where publication appears. But then also you have the smart specialization classification or the sustainable development goals. So how we can play with all these taxonomy. So in the project in Toscana, they created throughout the ontology the possibility of matching and mapping all this information throughout an ontology, which in this case is a model that has been built and developed with experts. It's not a machine. It's really people that has been developing. Of course, you have also semi-automatic procedures, but it's really a domain expertise. And has been done also involving people at the regional level, at the national level for developing this together. So this is also a way of reinforcing collaboration while you work on building ontologies. And thanks to this, now what you can do, for example, you can explore, for example, what's happening in Tuscany. If you look at a European project, here you have, for example, disciplinary field, and you see how much project they are getting, but then you can compare with publication, or then you can compare with number of students, and then finally with job employability. All this category came from different data sources using different taxonomy, and we simply are able now to connect and exploit in a much more interoperable way. And then what we can do, we can also develop a lot of visualization using this data. If you explore the website, I'm not going to do now for time reason, but everything is online. So you have a lot of interactive visualization that you can explore, and all these visualization have been built starting from specific question. For example, in which area the research or the education regional system is more competitive, and or from which area of Italy students are coming to Toscana, in which field they are studying, and then you can navigate all this information and you can explore throughout a series of interactive visualization this information that originally are based in different data sets, but now are integrated throughout ontology and then are visualized, and you can navigate and then you can explore. Moreover, you can also build internal tools. Of course, these are visualization which are public. You can go, you can explore, you can navigate, and are being conceived also for public interest. But then the region also decided to build an internal tool, which is where they really look at indicator, data, information for more strategic purposes. And they build an internal dashboard, which more than 80 indicators, which exploit all these different data, but without knowing where the data are. They just query the ontology, and the ontology is directly going to the different data set, exploiting different information and showing some visualization which can give some information about specific indicators. In this way, what we can say, so with the fact that the semantic technology are really useful in helping policymakers, because allow the possibility of discovering data throughout the connection between different data. And this can be data, and this data can be in different format, in different data sources, and we can just exploit this data using the ontology-based technology. And the ontologies, and for this reason, allows us to correlate also different taxonomy, and especially very important for policymakers, include also a posteriori classification, because this happens constantly. We design today a classification, a taxonomy, and then tomorrow new technology appears, new taxonomy arrive, and we need to remap this information. And this is where this approach can be very powerful, because allow this combination. For example, here in this picture, you can see another example, the correlation between cancer research, where we can correlate in incidence and mortality, and then also the funding and also the publication. So we can really explore this kind of correlation. And then of course, this can also tell us in case we decide to invest money or support science more oriented to certain things. Of course, for doing all these things, it's super necessary that public administration encourage the use of linked open data, which is the model in which we are sharing this metadata. So if you take what also the European Commission is telling in terms of how we should share data and how the data should be interoperable, linked open data is what they call the 5-star model. So it's the best way of sharing data. And not everyone is still doing this, because of course, this requires an effort, which is not just publishing a PDF or a CSV file, but of course, if we want to be able to exploit this information in a much more smart way and exploit the semantic behind the data, we need to do this effort in publishing the data in this format. And this is why a lot of public administration are working more and more in building these ontologies as a possible standard solution, and we just need to use it, because we are now plenty of these. Simply, sometimes we don't know, and we don't exploit this information, and we reinvent another one. One maybe this ontology is already there, it's already a standard, and we just need to map our data with respect to this model. And I will just stop here, because maybe if you have questions, it's more interesting to be able to exchange also with you.
Yes, thank you very much, Mr. Rondelli. I think that there are questions, and also probably the issues related to the indicator is also quite important to discuss also with you. But I think that if you agree, we could go in the direction of completing first this session concerning the ontologies and policy visualization tool. And later on, we will come back to some final question and final greetings to everybody. What I would do now is to leave the floor to Mr. Francesco Molinari. He's an international researcher and policy advisor within more than 20 years of experience on research and innovation projects and programs at regional, national, at the European level. He's also a PhD researcher on AI at the Department of Computer Science at the University of Rijeka, but he's also cooperating with Polytechnic of Milan, of the Department of Architecture and Urban Studies. And he's also a member of the European Commission AI Watch team that is delivering this European roadmap for artificial intelligence. So please, Francesco, the floor is yours.
Thank you, Marco. Can you see my slides?
Yes, Francesco.
Now can you see the next slide after the title?
Yeah.
Okay,
sure.
So everything works fine. I will try to be short. I don't have many slides with me, and I will try to, first of all, wrap up what has just been said, and I thank you very much, Bernardo Rondelli, because he exhausted, so to speak, the topic of ontology, giving me the opportunity to stay focused on the other side of this panel discussion, which is policy visualization. But before going there, this graph shows a bit of a summary of what the previous three presenters, Professor Martin Cicipsic, Professor Lopes, and Dr. Rizzo, showed to us when they spoke up in different ways about machine learning, text analysis, and natural language processes. They showed us that these technologies have not only the potential, but an actual and concrete capacity to serve some interests of policymaking in terms especially of discovering hidden patterns and associations between words, sentences, documents, belonging even to heterogeneous corpora. The applications can be manifold. We have listened to the speakers speaking about, for example, sentiment analysis of social media, fighting against fake news, deeper and quicker reading of research or policy papers. And these are all elements of a picture that is less and less hampered by the limitations of technology. Same goes for Bernardo's presentation, which basically showed us that ontologies can successfully act as a middleware layer between the repositories of data sets existing in every public sector organization and the different opportunities and possibilities of disclosing the contents of those repositories in a disciplined manner to users who may be either internal only to public administration or also include normal people, citizens, businesses, the clients, the customers of public administration. There are many advantages in doing so by the use of ontologies, and like I said, Bernardo's presentation was so accurate that I can skip further considerations. Not before showing you this diagram, which is not meant to be disclosed or commented further by me. This is taken by the corporate website of a successful US-based startup company, which is showing in different ways and with more detail the same concepts that Bernardo presented before or were in my previous slide with the 3 layers. This is not theory, this is not ongoing research, this is a real company that is active on the market, offering services to enterprises and maybe also public sector organizations based on a concept that you can retrieve on their website, speaking about catalog as a service platforms. Now let's go to the specific topic of my presentation, which is about an ongoing work in the project that is companion or the heir of the previous project, where the University of Bari and Pasquale Lopes developed all the technologies that he presented before. The idea here is to make use of another tool, visualization tool, that is known since many years, both at theoretical level and practical level, but in other industries, so to speak, than in public administration. It is named oriented Bayesian nets. Let me reassure you that the approach that I want to follow is not to say that, okay, this is another rabbit, no, that I want to take out of the hat and sell you. The idea is to demonstrate that it may have value for the purposes of public administration in general and policy making specifically, as it is the title of this workshop today, AI for policy making. What are oriented Bayesian nets? They are visual representations of probabilistic models, where the essence that characterizes these nets is this orientation you see from left to right in this example, given by the arrows. Each node is a variable of this model, which is associated with a distribution of probabilities. Probabilities of events to occur, in that case, the node will correspond to an event, or probabilities of certain decisions to be taken, in which case the node becomes a sort of decision-making node, where the advantage for the user, for the policy user, is that he or she can navigate along the network so that the ultimate, the ending point of any combination of events and decisions associated with their probabilities can be known in advance. In advance means before the decision is even taken. Why is this interesting for policy making? Here I must open a very quick window on what political science, and unfortunately also a big branch of ICT for policy modeling science, has long defined as the template of an ideal policy process. This template here, shown here, if you Google for policy process, you have very high chances that you will find a picture like this as a result of your search. What is the problem in this picture? Nothing specifically if you look at the 5 stages that are described, because in every policy process there can be an initial setup of an agenda, the policy can be formulated, then decisions taken, implemented, and finally evaluated. And based on the results of the evaluation, we can hopefully have a revision of the agenda. The problem is that this configuration is cyclical. It goes like a loop. But in practice, this is not what happens in reality. For example, in this quote from a very famous and respectful political scientist, Sabatier, the argument is made that reality doesn't go like this. In the very least case, will cycles interact with one another to bring back, to bring themselves back to a unitary definition, to a unitary description. In any case, no way to bypass the timing aspect. And this is why our opposite proposal in this project is to look at the policy process as in the easiest simple way, as a way to translate goals into actions and outputs. Outputs which will be later, of course, evaluated and measured against the objectives and the KPIs. And here comes my contribution to answering to Christoph Meyer's question on KPIs. One of the smart ways to look at KPIs in AI for policymaking is to compare the KPIs of an average or ideal policy process with and without the addition of any AI tool. I was mentioning the dimension of time. This very fuzzy picture only says one thing, that even if we take the simplest representation of a policy process, time is very relevant in two directions, not only because once the goals are set, then the actions occur across time and then the outputs are probably gained, or to some extent they are, or not at all. But there is continuous feedback from, you see, the outputs and the revision of actions and the revisions of goals. This feedback mostly occurs across time. And this creates the messy situation which, in my opinion at least, the cyclical model oversimplifies, not considering the advantage of looking at the process as linear. The process is linear, but it is also context-based. I cannot go very in much detail here, but we can consider at least two contexts as relevant for this process. One is the institutional context, which describes and sets up the rules of interaction for all the many policy actors and stakeholders who are involved in the definition of the policy agenda. And the second context, which is in this representation broader than the institutional context, is the thematic context. Are we speaking about policies in the domain of energy, in the domain of urban development? What else? Depending on the context, there will be different policies, as it is obvious to everyone. So now let's go to the final points that we are making now in relation with this graph, which I don't have the intention of commenting. It is only a way to show you again how these decision-making trees or oriented Bayesian nets can work in practice. What this graph tells us, very quickly, and then I will jump to the next and last of my slides. This slide says that Bayesian networks have been used in a variety of modeling contexts and purposes, typically in industrial and manufacturing domains. And then they have been opening up to more and more uses, but never in the public sector, for two fundamental reasons: that they can handle both qualitative and quantitative data. Remember the presentations of many of the speakers who were before me, and they can work fine even if the underlying model, the way policy works, is only partially known or incompletely described. And how can this second advantage materialize? It is described with this picture, which is only an example. Again, the node, the yellow nodes, represents either events or decisions, and you see that at every node there is a distribution of probabilities associated to choosing that direction or bearing the consequences of a certain event that materializes with a certain probability. If you navigate, in this case from down to top, following always the direction of the arrows, these exemplary oriented Bayesian nets, then you can figure out for a certain policy process what can be the different options, the different landing points, and the different probabilities of reaching certain outputs or outcomes. So what is our goal in this project? And now I will conclude with a call for action that affects each and every person listening to this presentation, not only now, but also on our official website when this will be available for downloading. Our project has identified 3 macro policy areas. 1, open innovation for society. 2, industrial transformation. 3, sustainable development. Needless to say, these are very hot topics for each and every national, regional, or local government. What we are in the process of doing is to define at least 10 policy processes belonging to either of these 3 families, to map them by the help of these oriented Bayesian nets, to procure the convergence of interests for the identification of these processes from as many policy stakeholders in the Mediterranean and European area as we can. We are reflecting on the launch of an online poll, which will be very simple, but also very informative for us to decide whether in which direction we should go to identify these 10 policy processes. Then what we want to create is a collection of working groups for the interpretation of these policy processes. So ideally, we have a KPI, we have set out a target of at least 5 working groups. So once we have the 10, we will have 5 of these 10 policy processes, which will be discussed, animated, completed with their ideas and proposals by policymakers, civil servants, and other public sector stakeholders from all over the Mediterranean area. To join this show, you are kindly invited to email us, and you will be later offered the opportunity of other similar working groups or workshops like this one to contribute with your comments to the definition of these processes. Still an experimental definition, but we sincerely hope that based on your inputs, we will be able to identify at least 5, maximum 10 policy processes that are really touching the flesh of public administration in this historical moment. And so in case you are interested, just email us at the address that you see here. Thank you for your attention.
Thank you, Francesco. Also from your side, we are pretty on time. We at least transformed the roundtable during the webinar because of the different timing constraint of the speaker, but we still have few minutes for some very last questions. I see here a question to Mr. Rondelli. I don't know, I suppose he's still here. Am I wrong?
Yes, I'm here.
Yes. I don't know if you're also able to see on a chat the question, but it refers to the fact that in policy domain, people with different but overlapping perspective on how to act need to communicate between them. And this would translate into multiple overlapping ontologies. how do you deal with the issues of overlapping but yet diverse concept informed by political values while developing the ontologies?
Yes. I didn't have time to go in detail, but normally when we talk about ontology, we have to differentiate between what they call top level ontology, which is a very wider description of certain problem. And then we can have more at a sort of hierarchical level, we have more domain related ontology. So we can have different representation of the same model, but they can refer, we having similar concept to more generic one. So this also allow the possibility of keeping a different view of the same question, the same domain. So this is really an added value when we work also with ontology, because we have the possibility of connecting concept throughout different level of hierarchies. And this is interesting because we can build a semantic perimetry in a different ways.
Yeah, that's clear. Good. I don't know if Christoph Meyer is still, yeah, I suppose he's still with us. I don't know if Christoph, do you want to, reply on the proposal that Francesco was saying concerning the indicators that I saw? It's a quite tricky question, the ones that you mentioned at the very beginning. Are you aware that part of this studies, of this even webinar can address, is the right way that you think we could address also specific requirements concerning the measurement of the results, or do you want to comment on this?
Yeah, thank you, Francesco. I think it's yes, it's an interesting point, but I want to raise now an additional point, because seeing the explanation at this interface between artificial intelligence and policy, I can follow from the logics of why also the selling point. I can follow in a lot of ways the logics of efficiency, and this is also perhaps probability, and all this goes in the direction of efficiency. But I have a difficulty to find the logics of transparency, which is also very important for public decisions. And when we talk about black boxes and okay, we are in the end, we can perhaps, we have time, we can already, this is also very important, especially now when we are in a situation of crisis. But a lot of times we have also a transparency problem. And my question is, do you have this on the radar also? And what are you doing on that side?
Yeah, thank you, Christoph. Maybe I can address this question probably to Francesco, or even to Mr. Rondelli. Yeah, this is an issue, and maybe also Mr. Molinari can try to give his point of view.
In my opinion, it's not an issue, it is the issue. Because we have struggled so much in the past to make the public decision-making more transparent to citizens every time people are involved. And we are still struggling, for example, in the procurement law implementation, with issues related to how tenders are awarded, and if the evaluation process was fair or unfair. And we are still speaking of processes that are completely handled by human beings. Now we have a situation where the algorithms, as also you, Marco, mentioned in your question to Sanda before, the algorithms are not transparent. And there is a business interest in not making them transparent. And sometimes also not only a business interest, but also a way to protect decision-making against intrusion. But on the other hand, apart from transparency, we also have accountability, which is another principle very important for public administration. Accountability means being able to explain to the citizen the way a decision was taken. So for me, the challenge is not that much to show to normal people, to lay people, the way each AI-supported processes actually worked. But the very tough challenge for the coming times, in case these AI technologies take hold, is to create a new and capable policymaking and civil servants class that is able to understand the limits and the potential of these technologies, make up their own minds, take the best decisions for the public interest, and be able to explain, in case of questions, the way processes were built. I know it is a tough challenge. I know we could say no thanks, but this is a trend. I think the previous presentations showed that very clearly, where technology-related problems are less and less important. And what is now happening is that the domain of application is not ready yet, especially in the public sector. But just to finish with this point, let me also mention the results of a recent study that was published last year on the occasion of the COVID-19 crisis. Someone started to evaluate the behavior of the so-called experts, not artificial experts, human beings. And the results were deceiving, because the experts typically exhibited superior performance only in very narrow domains, while at the same time having the tendency to speak also in domains where they didn't have superior knowledge. And the result was that in some cases, the decisions taken by policymakers were supported by false or less reliable advice received from very well equipped and knowledgeable experts in related, but not exactly in those domains where decisions were being taken. This is another challenge which we should take into account while balancing the pros and cons of using algorithms instead of human beings as advisors.
Okay, thank you also for this. Just to say that, yes, Christoph, these are issues which are in our radars, and this is, of course, the challenges that we have to focus and to face with, also because sometimes, as Mr. Rondelli was saying, we are not able to use the linked open data, or let's say transfer the responsibility or the trustness on what is already existing in terms of linked data and in terms of relationship among the information that are already available on the public databases. But this is an issue also together with some other aspect that we are facing with, but we suppose that also this sharing of experiences is a pathway that we have to follow, and we expect that also the outcomes of the work that we are going to do in the coming months can provide answers to this question and answer to these issues. I don't know if there are other questions. We already are 7 minutes late with our expected ending time. So I don't know if Jana or Anna also from our side has specific issues to raise or even communications. I saw that in the chat there has been an exchange of links where you can find the registration as soon as it will be available, but also links to our community where the slide and the presentation will be published. If we don't have any other issues to treat, I would close here this workshop. And I would like to thank you all. There has been time where we were more than 80 people, so I suppose this is a criteria to also check the issues that we are treating here. I definitely thank you all for being here and give you the appointment for the coming actions of the social and creative project activities, and we will keep in touch by email and for the upcoming workshop. So thank you everybody for staying with us, and we will keep in touch.